Hi, hello friends. Welcome to T Academy. Now I am going to discuss the yesterday's paper, that is Telangana State Southern Power Corporation Limited. So TSSPDCL 2022 paper. So which is held on, that is 17th of July 2022. Okay. So this paper will have two parts. There's a part A will have a technical questions of 80 questions, and the part B will have a general studies questions of 20 questions here. So total will be 100 questions here. And in this one, I'm going to discuss the part A question paper. Now, for this answers and solutions, I'm going to use the set B here. So the question that I'm discussing is a set B here. Okay. So set B here. Okay, so I'm making especially this video for my YouTube subscribers and my followers. Okay, so the first question here it is, that is from the instrumentation engineering. The question number is from the part A and the two technical part. So here the question here it is, the question is, in an instrument the transformer, the errors can be reduced to. Okay, so here, so instrument transformer, okay, the errors can be reduced by, so it can be reduced by using the low reluctance core here. So why it is low reluctance core, sir? So reluctance means it is a low reluctance means it's our more the flux. So more the flux means the errors will be reduced here. So the answer will be A here for this question here. Okay, the next question here it is, a 0 to 300 volts voltmeter has an error of 2% on full scale deflection. If the true voltage is 300 volts, then the range of reading on this voltmeter will be. So these two questions are previously have seen in case of my ISRO videos, okay, ISRO question papers, in which the solutions for these videos are given. So now I'm repeating again. A 0 to 300 volts voltmeter has an error. So for a range of 0 to 300 voltmeter, okay, sorry, is the pointer should be here like this. Okay, okay, so it is having 2% error, means for 300 volts 2% error means 2 divided by 100 here. So how much voltage? It will giving an error of 6 volts here. So for a range of 300 volts, so this error remains constant irrespective of the voltage you are measuring. That means if you are measuring with the 30 volts, so plus or minus 6 volts will be there. Okay, so either it may read 36 volts or either it may read 24 volts. That means the reading of this 30 volts measurement will be in the range of 24 to 36 volts only. Okay, hope you understanding. Suppose if the same range, suppose if they give 40 volts here, so 40 plus or minus 6 volts, that is a either it may be 46 volts or it may be a 34 volts like this. Okay, so answer for this question will be, that is 24 to 36 volts. Next one, see here, if two 300 volts full scale voltmeters V1 and V2 having a sensitivity of 100 kilo ohms per volt and 150 kilo ohms per volt respectively are connected in series to measure 500 volts, then so which reading will give the maximum value and which reading will the uh, lesser value? So directly I'm using the formula here. So theoretical means you need to convert this resistance per volt into total actual resistance, then you have to apply the voltage division rules. So without doing that, what I'm doing is I'm just applying a formula here, that is a V1. So V1 is equal to, so total voltage V2 into, that is a S1 divided by S1 plus S2. So this is the formula that I'm applying here. What is this one, sir? So Vt is a 500 volts into, that is S1 is 100 kilo ohm per volt divided by S1 plus S2 means, so it is 100 ohms kilo ohms per volt plus 150, because they are in connected in series. So total will be, it will be 250 kilo ohm per volt. So kilo ohm per volt gets cancelled here. So 251 250 into 2. So it is 200 volts. And similarly, if you find the value of V2, that is the total voltage Vt into S2 divided by S1 plus, oh sorry, S2 here, S1 plus S2, that implies it's going to be 300 volts. That means the voltmeter 1 will measure up to a 200 volts. Similarly, voltmeter 2 will measure up to 300 volts. So answer will be C here. So V1 will read 200 volts and V2 will be read 300 volts. So as compared to previous Tsspdcl paper, so this paper is somewhat easier compared to the previous paper. Okay. So by mistake, voltmeter and ammeter are connected as shown in the figure here. Okay. Now the options are here such a way that so which meter is going to be burned away. Okay, simple. See here, whenever you have a voltmeter, the voltmeter ideally speaking it will have a resistance of infinity. Similarly, ammeter will have a resistance of what? Our ammeter is going to be 0. So when the resistance is 0, ideally I'm speaking, okay, this single phase supply is going to be short circuited like this because of this armature, I mean RA resistance will be 0 here. And what about here? So voltage of this voltmeter is infinity, and so it act as a open circuit. Here act as a short circuit. As we know that short circuit is current is higher compared to its full load current or normal current. So short circuit current is very high. As the short circuit current is very high, what about the IS square R losses? So I square R loss will be high. So this will generate the heat. This will heat is going to be higher, means it's going to be burn the meter. So, okay, so it's going to burn the meter with a smoke or heat, you can say. So answer will be ammeter is going to be burn away. Voltage is not, I mean voltmeter is not going to be burned because it is having infinite resistance. Current will not flow. No current, no means no I square losses. No I square loss means no heat. No heat means no burning. So answer for this fourth question is it's a here. Okay, so let's move to the next question here of this video, right? Okay, so here we have a question that is mixed up with a measurement and as well as networks. So we'll consider as a network question. Two wattmeters are connected to measure the power power in a three-phase balanced delta connected load reads. Okay, when there is a delta connected load that reads the value of W1 as a 12 kilowatts reading, and W2 will be what? 15 kilowatts reading here. Expectedly. If the same load means all the whatever the components are there, that means either it may be R or it may be L or it may be C. The same components again we are using. I am just converting this delta network into what I am doing. I am going to make a star network here. Now in this star network, what is the value of W1 and W2? Okay, so the wattmeter readings of the W1 and W2 will be what? So simply, if there is a 12 kilowatts, when you are converting the star to delta to star, this value is divided by 3 here. So 12 kilowatts by 3. Okay, similarly 15 kilowatts divided by 3 here. So because of this reason, so there will be 4 kilowatts and this will be 5 kilowatts. Sorry. So that I can guess the answer as B here. Okay. Now next point, next question here. So this is from the EMF, electromagnetic fields, right? A point charge of Q is equal to 20 into 10 power minus 9 is placed at the origin. How far long the negative axis will have a potential of 60 volts here? Okay. So this is the question they asked here. So here I'll make it down. Okay, right. So like this. Now here the point charge is Q. Now there will be a some distance here. The distance will be x. So distance will be x here. Okay, x here. Now so what here we have a 60 volts. Sorry, here we have a 60 volts here. Now what is the formula that I'm going to use here is V is equal to Q divided by 4 pi epsilon naught into R here. So Q value, you know what is the Q value? 20 into 10 power minus 9 divided by 4 pi into epsilon naught, means you know that value. That is, what is the value? It is 1 by 36 pi into 10 power minus 9. So epsilon naught value into R value. So from this you need to find the value of R here. Okay, what is the value of V here? V is nothing but 20 into, sorry, V is nothing but 60 here. I'll repeat here. 60 is equal to 20 into 10 power minus 9 Q divided by 4 pi into 1 by 36 pi into 10 power minus 9 into R. So this value you need to calculate. So by substituting this value, R value will be equal to 3 meters. So answer is A here. Okay. So next question is, the ramp function can be obtained from the unit impulse function at t is equal to 0 by. Okay. So it is simple question. You have to arrange the order. So parabola, ramp, step, and impulse. So if you are going in this manner, it will be differentiating, and if you are going from the this manner, it will be integrating. Okay. Now the ramp function you need to calculate can be found from the unit impulse. That means what is it you have to do? You have to integrate this impulse. Okay, unit impulse function. So the ramp function can be obtained from the unit impulse function by integrating the impulse function how many times? Twice here. So once you are doing integration means it's going to be step. After the step is going to be ramp here. Okay, so you have to twice integration. So integration first time and you have to do integration second time. So answer will be D here. Next one. For a periodic signal, V of t is equal to 300 sine 330 sorry 30 into sine 100 t plus 10 cos 300 t plus 6 sine 500 t plus pi by 4. The fundamental frequency. The fundamental frequency means this is a fundamental frequency in radians per second. So this value is nothing but it is nothing but 2 pi f. Okay, so omega t also we can take. So this is nothing but omega. Okay, so omega t is equal to 100 t. Its radians per second means omega equal to what? 100. So simply answer is B. Okay, next one. The function f of t is equal to sine of 1.1 t plus sine 3.3 t has a time period of. So here the function f of t is equal to sine 1.1 t plus sine 3.3 t has a time period of. So here we need to find the time period here. So as a time period, first I will take this fundamental value. Okay. So omega t is equal to 1.1 into t. We know that omega is nothing but what? 2 pi f is equal to 1.1 here. So we need to find the time period. So 2 pi f I can replace it as 1 by t is equal to 1.1. So t is equal to 1.1 by 2 pi. So what you will get is a 0. So here I am mistaken 1 by t here. So 1 by t is equal to 1.1 by 2 pi. So from this t is equal to, okay, so 2 pi by 1.1, which can also be written as pi divided by 0.55. So answer will be C here. Okay, let's move to the next question here. All right, so this question, a band limited signal with a maximum frequency of 7 kilohertz is to be sampled. According to the sample theorem, the sampling frequency in kilohertz which is not valid. So the valid values are, okay, so as per sampling theorem, the valid values will be f must be, okay, fs must be greater than 2 times that of the f maximum frequency. So as per that, okay, so greater than or equal to 2 into 7, that is nothing but greater than or equal to 14. So whatever the values above 14 are valid. So 15 is a valid, 18 is a valid, 21 is a valid, but if it is not valid, not valid means it's a 12 kilohertz is our answer for this question here. Okay, now here very simple question from the DC machines. A DC shunt motor is connected to, DC shunt motor is there. Okay, let me take the armature. Okay, now one DC shunt motor is there. Okay, so let me choose a different color here. Okay, DC shunt motor is there. Okay, it's not visible properly. I'll take one by one. Okay, right. So DC shunt motor is there. Okay, takes a current of how much? Line current of 11 amperes is going to take. What about supply voltage? 220 volts. Okay, fine. And having a armature resistance of 0.2 ohms and a field resistance of 220 ohms. Okay, fine. Okay, now what is the generated EMF that we need to calculate here? Now here if it is there, what about the armature current here? So here we have a 220 volts and 220 ohms is a resistance. That means here we'll have a current of 1 ampere. Total 11 ampere current taking. So 1 ampere is going here. What about here? It is at 10 amps here. Yes or no? Right. Now back EMF. So EB in case of DC motor, EB is nothing but V minus IA into RA. Okay. So what is the value of V? V is nothing but 220 minus armature current is at 10 amperes into resistance will be 0.2. So this will be equal to 220 minus 2 volts, which is equal to 218 volts. Simple answer 218 here. Okay. So next question here. See this question. A three-phase 6-pole induction motor on full load runs at 920 rpm. Okay. It is supplied from a 4-pole alternator running at 1500 rpm. Calculate the full load slip of the motor. So yes, we need to calculate. S is nothing but ns minus nr by ns here. So first of all, a three-phase 6-pole induction motor on full load runs at 920 rpm, right? So it is supplied from a 4-pole alternator. What is the 4-pole alternator speed? It is a 15 rpm. So from this we can calculate ns is equal to 120 f by p. So ns is 1500, 120 into f we don't know. Okay, generally f value will be 50 assumption. Okay, see, we'll check here. So 4, so 4 1 and 4 3. Okay, it's going to be f is equal to 1500 rpm, sure. Okay, so sorry, sorry, it's not 15 rpm. F is nothing but 50 hertz, sorry, mistaken. F is equal to 50 hertz, we got it here. Now same formula, induction motor. So induction motor is running at 920. NR value is given. What about the NS? So NS for the induction motor, NS for induction motor is equal to 120. F value will be 50 divided by P is 6. So it is 1000 RPM. So nearest value is 1000 RPM. Okay, now we need to find the value of slip. NS value is 1000 of the induction motor and NR value is 920 divided by 1000 here. So 80 divided by 1000 is going to be 0.08. So answer for this question will be C here. Next one. So let me take the next question here. All right. A 12-pole induction motor fed from a 1000 head supply. If the frequency of the rotor EMF is at full load is 2 Hz, find out the full load speed here. So here also we need to find the value of speed, but here the given is the frequency is 2. Okay, 2 Hz is given. Now we need to find the full load speed here. So S is equal to ns minus nr divided by ns. What is the ns value here? Okay, so here we know the relationship between this fr and fs is, so fr is equal to slip times that of fs here. Okay, slip is nothing but fr is at 2, fs value is nothing but what, 100. It is nothing but 2 by 100. Okay, now we know this value, that is at 2 by 100. Okay, so into, I'm directly substituting here, so into ns value. What is ns value? Ns is equal to 120 f by p. It is nothing but 120. Frequency is 100 divided by how many poles? There are 12 poles. That is, it is going to be, so 1000 rpm. Okay, so into 1000 is equal to ns. Okay, ns is nothing but what, 1000 again. So 1000 here, there is 1000 minus nr here. So we have to find the value of nr. So here 0 zeros, 0 0 gets cancelled, 20. So nr is equal to 1000 minus 20 is nothing but 980 rpm. So answer will be B is the right for this question here. Okay. So let's move to the next question. Now, a three-phase transformers, each of 100 kVA, each of 100 kVA rating are connected in delta If one of the transformer is taken out of the service, then capacity of the system will be. So when we have the delta open connection V to V is nothing but, which is when there is a 300 kVA transformer, total capacity is going to be 300 kVA. Okay. Now when we have 300 kVA capacity, one of the transformers out means we have only capacity of 200 kVA. Okay, but it is not going to be supply the full load, as okay, the transformer is going to supply, that is a root 3 by 2 times that of is, that is, or nothing but a 0.866% of this total capacity of the two transformers, that is 200 kVA into 0.8666. Okay, if you are solving this, you'll get the answer as 1.732 kVA. So that is the answer here. Okay, so 1.732, or we can also say 0.577 times that of full, that means 300 kVA. So both also will give the same answer. So P will be the right answer for this question here. Okay, so right, this one, the 15th question here is about transformers. The efficiency of a 65 kVA transformer is 0.96 at full load as well as at half load. For this transformer at full load, the copper losses will be. Okay, so we can discuss this question with terms, in terms of the theory, in terms of graph also we can discuss. So, okay, I'll try to discuss with the problematic way. Okay, so here the transformer efficiency is 0.96. Case 1 I am going to discuss. The efficiency at full load I am going to take. So efficiency of the full load is going to be 0.96 is equal to, so 65 kVA divided by 65 plus the losses W I'll take. So W is nothing but iron losses plus copper losses at full load. Okay, so which is going to be what? Which is going to be, I'll take it as 2.708 watts. Okay, now similarly second case, 0.96 will be equal to, so 65, half of the full load means 65 by 2 plus 65 by 2 plus losses here. Okay, so once you are going to find this loss here, omega. Okay, so omega here is nothing but omega I plus omega 1 by 4, that's half of the full load, no? So omega C, which is equal to, so we'll have a 2.083. So once you are going to solve these two values, you are going to find that WC is going to be 1.805 and WI is approximately equal to 1.6. So from this you can observe that the copper losses WC is greater than that of iron losses. That's the conclusion here. Okay, if you are talking about the graph here, so you have taken this graph like this, and from this point, maximum point here, as the current increases, the efficiency is going to be fall down. Here we have iron losses, area copper losses. So WC is greater than WI. So answer for this question is, the copper losses is more compared to core losses. Okay, or iron losses is the answer for this question here. I'll move to the next question here. Okay, a half wave thyristor converter supplies a pure inductive load. So pure inductive load means the waveform is continuous like this. Okay, continuous like this. If the triggering angle of the thyristor alpha is going to be 100 degrees, the extinction angle. So extinction angle is nothing but alpha plus beta should be equal to 2 pi, or we can also say it is a 360 degrees. Why? Because a pure unity load and it is a continuous conduction mode. So from this, extinction angle beta equal to 360 minus, what is the value of 100 here? So simply 260 degrees. So answer will be A here. Okay. And the next question, from the power electronics, there are 12 questions asked in the power electronics here. A fully controlled thyristor converter is in the figure is fed from a single phase AC source. When the firing angle is 0, the DC output voltage of the converter is 300 volts. What will be the output for a firing angle of 60 degrees assuming continuous conduction? The fully controlled thyristor converter output voltage V0 is equal to 2 Vm by pi into cos alpha here. So when there is a firing angle is 0, this alpha value is 0. Okay, so V naught is nothing but what? 300 is equal to 2 Vm by pi. And similarly, we need to find at the firing angle 60 degrees. So 2 Vm by pi into cos 60. So 2 Vm by pi value we know. What is the 300? So 300 into cos 60, which is equal to 300 by 2, 150 volts is the answer. So answer will be A. Okay. Next question here. Right. Next question here. A single phase bridge rectifier is preferred over the full wave center tapped rectifier. Center tapped rectifier means we have the secondary winding like this of the transformers. We have some tappings here. We have a load here. We have a SCR here like this. We have a SCR like this. Okay, so this is a center tapped transformer. We have a R load assumption here. Okay, center tapped is there. A single phase bridge rectifier is preferred over the full wave rectifier, center tap rectifier, because in case of full wave center tap rectifier, the peak inverse voltage, okay, that is a 2 into Vm. That much rating has to be sustained by these SCRs. So it will increase the cost here. So cost is going to be increases here. So that is the reason why we are going to prefer the single phase bridge rectifier, where we have the peak inverse voltage is nothing but Vm only. Okay, so here the diode or the equipment, the devices, the switching device should have peak inverse voltage of 2 Vm. Here we have Vm is enough. So that's the reason why it's going to be increased. And another option also correct. Power factor is higher, but this one is more preferred compared to P here. So answer is D for this question here. So answer is D here. Okay, so we'll move to the next question here. Question number 19. An SCR is inserted between the voltage source of 200 sin 3 140 and a load of R is equal to 10 ohms. The firing angle is 120. Then average load current is. So here we need to find the average load current. Okay, so average load current is equal to, okay, it is Vm by 2 pi into R into 1 plus cos alpha here. So what is the Vm value? It's at 200 divided by 2 into R value is 10 into pi. Okay, into 1 plus cos 120 means it's minus 0.5 here. 0.5. Okay, now so here is going to be 10. Okay, so 10 by pi into 1 minus 0.5 means another 0.5, so 1 by 2, which is nothing but 5 by 5 amperes. So answer is B is the right answer for this question here. Okay, let's move to the next question. The average output voltage of a DC to DC converter can be controlled by. Average output of DC to DC control, or it can also be known as a chopper. Okay, so chopper control. So the answer is both the pulse width modulation and the frequency modulation. So where we are going to vary the T and the T values, that is a pulse width modulation and frequency modulation here. Okay, next question will be from the two-port networks. A two-port network is defined by the following pair of equations. I1 is equal to 2V1 plus V2 and I2 is equal to V1 plus V2. The impedance parameters of this. So I have seen the videos of the other institutes which are given the explanation, which are given the answers, but not the proper explanation. And also some of the questions, the answers are given is wrong. So what I noticed here. So let's start here. The two-port network is given, right? So first of all, we'll take the matrix of Y11, Y12, Y21, and Y22. This is a basic idea of writing this network here. So from this by comparison here, this is a Y11 is a 2, Y12 is 1. Okay, so Y21 is 1, and this will be 1 here. So this is the Y matrix. So Z matrix means Y matrix inverse. So for that, what you do is we have to find the parameters. So let me take A, B, C, D. We know that 1 by AD minus BC, D minus B minus C, A. So this is the answer. So AD minus BC means at 1. So D value is, I'll write it down here. So D value is 1. B value is as it is -1. Okay, C value is minus C1 and A value is a 2. So 1 -1 -1 2. So answer is C here. Next one. A three-phase star connected supply of phase voltage of 100 volts. So they given a phase voltage of 100 volts. 50 Hz is supplying three-phase star connected resistive load of 5 ohms per phase. 5 ohms per phase. Okay. Find the total active power supplied. So we are talking about the single phases here. I will take the total power will be equal to 3 into V phase into I phase, or I can say 3 into V phase square divided by R. So 3 into what is the phase value? 100 volts. So 100 into 100 into 100 divided by resistance value is 5 ohms. Sorry, let me correct here. So 3 into 100 into 100 by 5 square. Okay, square, right? Okay, now from this we can calculate 5 1 5 20. Okay, 20 into 3 60. 60 into 100 means it is going to be 6000 watts. So answer will be A. Next one, the voltage phasor of a circuit is a 10 at an angle 15 degrees and the current phasor is a 2 at an angle minus 45 degrees. The active power and reactive powers of the system. So single phase means we are talking about P is nothing but V into I. The angle between them is cos phi. Q is nothing but V into I into sin phi. So what is the V value? It's a 10. Current value is 10 into 20 into cos. Phasor difference between the 15 and the 45. That is the total is going to be 45 plus 15 60 degrees here. And similarly 10 into 2 into sine 60. Cos 60 means 1 by 2. So here 10 into 2 by 2, 10 watts. Q is nothing but 20 into sine 60 means it's root 3 by 2. So 2 1 are 2 10 here. So 10 into root 3. Root 3 means 1.732. So that is 17.32 VAR. So answer is 10 and 17.32. Okay. So next more question here. One more question, right? So two coils having a equal resistance. So resistance are equal. So let me take R1 and R2 both are equal to R value. But the different inductances are connected in series. So we have L1 and L2 which is not equal. The time constant of the series combination is, so time constant of series combination we need to calculate here. So let me take T1 is equal to L1 by R1, T2 is equal to L2 by R2. Now when they are connecting in series like this, what is a total equivalent? So T equivalent will be when they're, I'm going to add this L1 by R1 plus L2 by R2. Okay. Now when these two values are having equal values, then so okay here now the total combination here, so that is a T, the total combination is equal to, so L1 plus L2, there's a total L equivalent value, and the total resistance value is going to be 2 into R. Why? Because L1 plus L2 is here, R1 R2 is same here. Okay, so we can write this as L1 by R plus L2 by R divided by 2 we can write. That means T1 plus T2 by 2 we can write. That means what is the meaning? Average of the time constants of the individual coils here. Okay, why? Because the resistance is remain same here. So this is the total L equivalent and this one will be R equivalent here. So total combination equivalent values we are taking. So answer for this question is B here. Next one. The sinusoidal waveform of current is given by the following figure. Represent the current in the form of equation here. So first of all here when the temp t is 0, when the t is 0, current having a magnitude of what? I of 0 is going to be 9. So this value you have to justify. Okay, so from most of the equations you can justify this value. Now second condition is it is going to be, let us this value will be some 30 degrees here, 30 degrees. Okay, 30 degrees the current is going to be negative. That means at t is equal to 30 degrees or omega t equal to 30 degrees, I of 30 will be going to be 0 here. So check here which option is going these two satisfies these two parameters. Okay. So I of 0 means here 18 into sine omega t is 0 plus 30. Okay. So sine 30 is nothing but what? It is 1 by 2. So it's satisfied. Okay. And here also option D, I of t is equal to sine omega t plus omega t is 0 means 150. Okay. 150 means going to be negative value. So okay. Now next here omega t equal to 30, it should be 0. So I of t is equal to 18 plus sine 30 plus 180 means 150 means it's going to be 0. So answer is D here. Okay, if you want you can cross check here. If I of 0 is equal to 18 into sine 0 plus 150 here. So what is 0 plus 150? So 150 means it is nothing but sine 30. Sine 30 is about 18 by 2. So it is going to be what? 9. At the same time 30, so I of 30 is equal to 18 into sine 30 plus 150 is going to be what? It's going to be 180. 180 sine 180 means 0. Okay, 0 value. So answer is D here. Next one, to measure the total power on the three-phase system supplying a balanced load 2 watt meter reads 7.5 kilowatts and minus 1.5 kilowatts respectively. The total power is a combination of the wattmeter reading 1 and the wattmeter reading 2. Okay, so it is going to be 7.5 minus 1.5, which is equal to 6 kilowatts. Answer is D here. Okay, and next question here, it is from the analog electronics here. Okay, right. A 6 volts Zener diode is shown in the circuit diagram, has zero resistance and a knee current of 5 milliamperes. So knee current is how much? 5 milliamperes current is flowing. Then what is the minimum value of R so that the voltage across the diode does not fall below 6 volts? That means here the voltage is 6 volts only as the two are in parallel. How much voltage here? It is also 6 volts here. Now we need to find the value of this R value. Now first of all find the value of current here. How much current flowing here in this resistance IR. So in order to find that, apply the KVL in this loop. Minus 8.5 plus 100 into, let me take some value I here. So I plus 6 volts is equal to 0 here. Okay. Now simply uh, simplify this value. So I value is going to be 25 milliamperes here. So I value will be 25 milliamperes and 5 amperes is going here. Apply the KCL. Here IR will be what? 20 milliamperes. Now you know the value of voltage, you know the value of current here. R is nothing but V value is how much? 6 divided by 20 into 10 power minus 3. So R is nothing but V by I here. That is equal to 1000 into 6 divided by 20. So 21 into 25. So it's going to be 300 ohms. Answer will be D here. Okay, let's move to the next question here. Right. Okay. The multiplication of two binary numbers 1010 and 1011. So 1011 is nothing but it is the equivalent of 10 and this will be equivalent of 13. So the product you have to do is 10 into 13 is equal to 130. Okay, so among them you have to cross check your answers, right? So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 and 2 power 6. Okay, so 2 power 7. So it is a 2 power 0 means 1. It is going to be 2, 4, 8, okay, 16, 32, 64, 128. So in order to get the 130, so 1, 0, 0, 0, 0, 0, 1, 0. So answer will be, this is the answer. So answer for this question is going to be A here. So A is our right answer. Next one. Convert decimal 185 base 10 to hexadecimal. So 185 which is divided by 16 here. Okay, 11 quotient will be 9 here. Okay, 11 in terms of hexadecimal we can write as a B and a 9. So answer is B here. So answer is B9. Next one, the voltage gain of an amplifier without feedback and with negative feedback respectively 100 and 50. Determine the negative feedback factor. So to find the negative feedback factor, AF is equal to A divided by 1 plus A beta. So we have discussed so many times this value. If AF value will be what? It is a 50. A value will be 100. So 50 is equal to 100 divided by 1 plus 100 into beta. So substitute here beta value. Okay. So 51, 52. Okay. So simply 1 plus 100 beta is equal to 2. Beta value will be what? 1 by 100, which is nothing but 0.01 value. Answer is a B. Next one, the probability, if the probable density function of a random variable x is f of x equal to k into e power minus mod x minus infinity less than x less than infinity, then the value of k is, so k value is nothing but 1 by 2 here. So I'm not discussing the mathematical answers here. Consider the initial values of y dash is equal to y and y of 0 is equal to 1 using RK method of order 2 approximate values of y of 2 0.2 with a step size of 0.2 here. So this kind of problem we discussed in the previous model paper of Tsspdcl. Now here the answer for this question is it is 1.20. And next one, let f of x be the analytic function such that r of real part of f dash of z is equal to 3x square minus 4y minus 3y square, then f of z is, so answer is z cube plus 2i z square plus c. So answer is B here. Okay, so let's move to the next page of this video, right? The value of double integral of r e x square plus y square dy dx, where the r is a semicircle region bounded by the x-axis and curve y is equal to 1 minus x square is. So answer is pi by 2 of e minus 1 here. Next one, if z of f of n is equal to 3z square minus 4z plus 7 divided by z minus 1 whole cube, then f1 is. So answer for this question is 3 is the right answer. Okay, next come to the technical part of this paper. Okay, right. The flue gases after leaving the boiler in a thermal power plant passes through the following components. Once the boiler burns the coal and generates the flue gases, so boiler. After the boiler, it is going to be enter into superheater. So superheater, it will increases the temperature of the superheater, and after that it is going to be used for the economizer to increase the efficiency of the power plant. After that it is going to be given to the air preheater. Okay, after that air preheater we have a induced draft fan. So ID fan here. So if you see the order here, so superheater is the first option. After that EC economizer. After that that is a air preheater. After that ID fan. So among the options we have the correct option as a 3421. So answer is 3421 here, right? And this question is from the power systems. Same kind of question asked in the previous paper of this TS NPDCL paper or TS SPDCL paper. I don't know exactly, but same question I solved here. So in that one, I naught is equal to 1 by 3 times that of IA plus IB plus IC. So in this question, what they asked is a three-phase, three-wire transmission line carries the following currents in the phases A, B, C respectively. The currents are given. Calculate the zero sequence current. So what you have to do is add all these values and divide it by 3. You'll get the answer as 150 minus J50 ohms. So answer is this value. So substitute this value 1 by 3 and add this value plus this value plus this value and substitute here. You'll get the answer as 150 minus J50 ohms. So we have already discussed this kind of question in the previous videos here. And the next question, if the fault current is at 2100 amps and the relay setting is 70% and CT ratio is 300 is to 5, the plug setting multiplier is. So PSM is fault current divided by the relay setting into the CT ratio into secondary current here. Okay, so rated secondary current. That is, the fault current is at 2100 divided by relay setting is what, 70%, 70 by 100 into the current setting is a 300 by 5 amperes into 5. So substitute this, you'll get the answer it as a 10. So answer is A here. Now next, here this question. A synchronous motor is rated at 100 kVA, 10 kV as a reactance of 33 ohms. The percentage reactance of the motor is. So first we are going to find the value of X per unit is equal to X actual value by X base value. What is the X base value? X base value is nothing but it is V base square divided by S base. What is the VB square? So 10K into 10K divided by S base is what? The given 100. Okay, 100K. So once you are solving this, what you got here it is. So 10, 10, 100 gets cancelled. So KK gets cancelled. Here we have 10 power 3. Now X per unit. So X per unit is equal to X actual value is 33 ohms. Base value is what? 10 power 3. So 33 into 10 power minus 3. So this is the current value. If you want a percentage means percentage of X per unit is equal to 33 into 10 power minus 3 into 100. That is gain 3.3. So percentage X. So answer will be B here. Next. So these are the standard questions, and these questions are asked in the previous, when I'm discussing the MCQs of power systems, you have seen this kind of questions there. Now, corona losses. So PC is proportional to F plus 25. Okay. So PC1, PC2, all right. PC2 is equal to PC1 into, in case of second case, frequency is 0. So 0 plus 25 divided by, earlier case it is 50 edges. So 50 plus 25. Okay. So 25 divided by 75 into PC1 value is what? It is a 3 kilowatts per kilometer per phase. So 3. So it is going to be 1. 1 kilowatt per kilometers per phase. Answer is C here. So this kind of questions already discussed. That's why I'm not reading the question here. Okay. Next one. In a two pulse fully controlled bridge converter with a freewheeling diode, the width of the freewheeling diode current pulse is alpha equal to firing angle, assuming RL load is with a continuous conduction mode. So these kind of same questions that are there in the ISRO paper. So the examiner is thinking that the question papers, whatever they are there in the ISRO or some other examinations, they're simply copying and giving to you. So answer is 2 alpha here. Next one. In a single pulse modulation of PWM inverter, if pulse width is 72 degrees, then so we know that we can eliminate the fifth order harmonics. So answer is A here. Okay. A current source inverter is obtained by inserting a large value of. So current source inverter will have a battery DC supply and we have a large inductor so that the current will be a constant value so that it act as a current source inverter. So in inductance in series with a DC supply here. So this is nothing but a CSI. Suppose in case of voltage source inverter, that means there should be a value of voltage which is parallel here. Okay, so voltage source inverter will have a parallel capacitance. Current source inverter will have voltage source in series with the resistance. Okay, so please don't stop your preparation. We have notification of the NPTCL, so please continue your preparation and focus on the examination point of view, right? So exam is over means don't stop your preparation. So don't stop your preparation until you get a job. Okay, now a step up chopper, DC chopper has an input DC voltage of 200 volts and average output voltage of 500 volts. If the conduction time of the switch is 150 microseconds, determine the pulse width of the output. So pulse width of the step up chopper will be like this. Here we have a T on and here we have a time period. So difference between the time period of T and T on will tell us the pulse width here. Okay, so this is the pulse width here. Okay, we can tag as a T here. Okay. So first of all, step up chopper. So V naught value is equal to Vs divided by 1 minus delta value here. Now Vs is what? It is nothing but V naught is what? 500. Vs value is 200 divided by 1 minus delta. So from this delta value got is 0.6 here. Okay. Now we need to find the value of this T on to T. Okay. Now T on value you know. So first of all find the value of T here. So T on by T is equal to 0.6 here. So from this T on value you know. So T on value what 150 microseconds divided by 0.6 is equal to T, which is nothing but 250 microseconds. So total T value is nothing but 250 microseconds here. What about the T off is equal to capital T minus T on. That is nothing but 250 minus 150. So width of this one will be 100 microseconds. So 100 microseconds is the answer. That is a T off period. Answer is C is 100 microseconds. Okay, so please check the answers, right? A PWM signal can be generated by using, so PWM signal can be generated by using a monostable multi-vibrator. So direct question I am not discussing in detail. Next question, that is electrical machines are designed to have a maximum efficiency yet. So basic simple question, it said design at full load. Next one, here we have the induction machines question. This question is a little bit theory question, I mean extended question. An AC induction motor is rated 20 kV kilowatts, 415 volts, 3 phase, 4 pole, 50 Hz. It has a full load speed of 1350 rpm. This motor is operated by an inverter with a constant V by F ratio. So this is a hint here. The frequency of the motor is maintained at 40 Hz and the motor loaded at a half load. Determine the speed of the motor, assuming that the motor operating in a linear region of the speed torque characteristics. Okay, so here we have the first case, ns1 minus n1 should be equal to ns2 minus n2 here. So as per this concept, what is ns 120 f by p? So here we have 120 f by p. What is that 120? Frequency is 50 divided by poles are 4. Okay, so it is 1300. So sorry, 1500 minus running at 1350 should be equal to ns2. Now the frequency is changed here, so that 120 f by p again apply here, same formula only. So 120 into 40 by 4 here is nothing but what 1200 speed here, 1200 minus n2. So find the value of n2, you will get as approximately 1050 rpm. So among them I'll choose the nearest value, it has 1140 rpm. Okay, next one, 48 question here. The effect of inductance and capacitance on the transmission lines with the increase in the tower height. So tower height, that means, okay, so here we have transmission lines. If you are increasing the tower height here, what about the distance between the conductor and the ground increases? So as a distance between the conductor and to the ground increases, C is equal to epsilon naught epsilon r a by d here. So a is nothing but this here. Okay, area. Now here, what about the inductance? Inductance are going to be remain same. Why? Because inductance doesn't have a effect of this spacing between the ground and the conductor. Okay, so inductance remains same and line capacitance decreases as a distance increases value. Distance between the two plates increases. This is going to be decrease. Capacitance value decreases. So answer is C here. Okay, I'll move to the next question here. In a medium and long transmission lines, which of the following device is used to neutralize the Ferranti effect? Ferranti effect means the receiving end voltage should be greater than the sending end voltage at no load condition. So you know that's point. Now in order to control the voltage, higher voltage, in order to control the voltage, we are going to use a shunt reactor to absorb the extra reactive power generated by the capacitance effect and to neutralize it. So shunt reactor we are going to use here. Next one, an equipment has per unit impedance of 0.8 per unit on the basis of 66 kV and the 100 MVA. Determine the per unit impedance when the base values are 33 kV and 200 MVA. So you know the basic formula and just substitute here. What is the basic formula here? X per unit is equal to nu is equal to X per unit volt into MVA new divided by MVA old value into KV base old square divided by KV base new square. So from this 0.8 MVA new is what? 200. Old MVA is 100 into MVA new 33 kilovolts square divided by 66 kilo per square. So answer is 6.4 per unit. So 0.8 into 8 you will get here. It is 6.4 per unit is the answer. Okay, some of the institutes are given 3.2. This is a wrong answer. Next one. What is the current gain of a transistor in a CC mode given that it has a current gain of 0.98 in CB mode? So the given question, they given the value of current gain alpha in CB mode and they are asking to find the value of current in CC mode. So we know the current gain in CC mode gamma is equal to 1 by 1 minus alpha. So 1 by 1 minus 0.98. So simply look at it as a 50. Answer is C here. Okay. Next one. Consider the op amp to be ideal in the following circuit if the V input voltage is what? It is a minus 5 volts here. Okay, so it's a non-inverting type amplifier. So V naught is equal to 1 plus RF by R. This RF value, this one is going to be R1 here. 1 plus R1 into the input voltage is minus 5 volts here. So 1 plus 2 kilo ohms divided by 1 kilo ohm into minus 5. So it is 3 divided by 1 into minus 5. It's minus 15 volts is the output voltage. So simple questions are asked in this paper. Okay, this paper is not that much tough. Okay, now here consider the op amp to be ideal in the following circuit. Determine the output voltage. There are two ways you can solve this paper here. Question here by using the superposition theorem. First, this one will be active, this one will be deactivated. Second case, this one will be deactivated, and this one case be activated. Like that, we can solve. Or I can sum up the two cases directly here. So what I am going to do here it is so V naught is equal to minus 7 kilo ohms divided by its R1 value. What is R1 value? It is nothing but 2.5 K into 5 millivolts. And similarly, this is the case one, and this 9 millivolts is deactivated. Now, similarly, if this second case 5 millivolts is deactivated and this one will be activated, means directly I'm writing the formula plus. Okay, so plus here, so plus of minus, so minus 7K only, again 7K only, and divided by why I'm making plus sign means to apply SPT. 7K divided by 3K into 9 millivolts. So solve this values here. We'll get it as a minus 35 millivolts is the answer. So answer will be C here. Okay, let's move to the next part question here. Sorry. If the amplitude of the gate pulse is applied to the thyristor is increased, okay, then the delay time would increase. Delay time would increase, but the rise time remains unaffected. The delay time will increase, the rise time will be remains unaffected. Next question from the power electronics. In the following figure, C is 10 microfarads, L is equal to 1 millihenry, V naught equal to 100 volts. The peak current of the diode is. So IP is equal to, okay, so V naught into square root of C by L. V naught is 100, square root of C value is 10 into 10 power minus 6 divided by L value is 1 into 10 power minus 3. So simplify this one here, 100, 10 into 10 power minus 6 plus 3. Okay, so 10 power 3 into uh, this value, so 100 into here we have 10 power plus minus 3, so 10 power minus 2 will have, so 10 power minus 2 means 100 divided by 10, which is nothing but what? It is going to be 10 amperes. So answer is 10 here. Okay, next The principle of homogeneity and superposition theorem are applicable to linear and time invariant systems only. Time invariant systems only. So answer is linear time variant systems. So answer is linear time variant systems here. Next move to question number 57 here. Given system f of s is equal to s plus 2 divided by s into s plus 1, the initial and final values of f of t will be. So here in this case we need to find the value of initial value theorem and we need to substitute the final value theorem. So when you are talking about the initial value theorem, so limit s tends to infinity s into s plus 2 divided by s into s plus 1. So initial value theorem. Now here what you are going to do is, so here we have s gets cancelled. Instead of taking the here initial value theorem, for initial value theorem f of t we need to find here. Okay, so initial value theorem we are substituting s is equal to infinity here. So I will make a s common here, that is 1 plus 2 by s, and again here limit s tends to infinity initial value. Okay, now here we have 1 plus 1 by s here. S gets cancelled. If you substitute the s is equal to infinity, so we have 1 by 1. So 2 by infinity means 0, 1 by infinity means 0. We have 1 by 1, its value is 1. And similarly, final value theorem. So limit s tends to 0. Okay. So s into s plus 2 divided by s into s plus 1 here. S gets cancelled, and 0 plus 2 is 2 by 1 is nothing but answer is 2. So answer is 1 and 2. So A will be the right answer for this question here. Okay. And the next question, the Fourier series function of f of x is equal to sine square x is 0 0.5 minus 0 cos 2x here. Next one, the transfer function of the system is given by z of s equal to v of s by f is equal to s by s plus 3. The system is at rest for t less than 0. What will be the value of v of t for t greater than 0, t greater than 0, if I of t is 3 into u of t? Okay, so v is nothing but I into r, simple formula here. Okay, so v of s is equal to s by s plus 3 into I of 3 into u of t. So u of t means is nothing but 3 by s here. So we need to transform into s transform. So here s gets cancelled. 3 divided by s plus 3 into u of t here. Now inverse Laplace transformation of this, inverse Laplace transformation of this is going to be 3 into e power minus 3t here. So answer is C. Next question, the 60th question here. The phasor is rotating along with angular velocity of 628 radians per second. Determine the frequency of the phasor and its time period. So omega is equal to 2 pi f. Okay, so 628 is equal to 2 into frequency is what? 3.14 into frequency f here. So from this f value is nothing but 100 hertz, and the time period t is equal to 1 by f, that is equal to 1 by 100, which can be written as a 10 milliseconds. Answer is A here. Next one, the 61st question here. The number of solutions of the system equation x plus 2y plus z is equal to 2, 3x plus y minus 2z is equal to 1, and 4x minus 3y minus z is equal to 3, and 2x plus 4y plus 2z is equal to 1 is. So answer for this question is B. The value of the integral z is equal to pi by 2 dz by z square sin z is, which is nothing but pi I by 3 here. So answer is 62 is D. Okay. And next, if u of x comma y is a solution of 3ux plus 2uy is equal to 0, u of 0 comma y is e power minus 3y, then u of 3 comma 2 is, answer is C. The work done by the conservative vector field f bar is equal to yz I cap plus xz z j cap plus xy k bar along with any smooth curve C joining the point a of minus 1 comma 3 comma 9 and b of 1 6 minus 4 is. So answer is A here. Okay, and then next question, if the Laplace transformation of t is equal to cot inverse of s, then f of t is sin t by t here. Okay, so next one, 66 question, control systems questions here. An open loop system represented by the transfer function g of s is equal to s minus 1 by s plus 2 into s plus 3. So here the poles are lying on the left half of the s plane. That is a minus 2 minus 3. That means it's a stable system. Then all the poles are lying on the LHS, means all are LHS means it's a minimum phase system. But one 0 is lying on the minus 1, so it is a non-minimum phase. So it is a non-minimum phase, stable and non-minimum phase system here. Okay, the closed loop transfer function of a system is t of is equal to 4 pi s square plus 0.4 s plus 4. Then the steady state error due to the step input is. So first it's a closed loop transfer function. We need to convert it to open loop transfer function. So OLTF will be equal to 4 divided by s square plus 0.4 into s. Okay, so these are transfer function here. So now steady state error we need to calculate. So ESS is equal to limit s tends to 0. Okay, so limit s tends to 0, steady state means s tends to infinity here, s tends to infinity, and here we have s. Unit step is means 4 into 1 by s divided by s into s plus 0.4. So we know that this value will be, okay, so infinity, and steady state error steady state error is equal to 1 by 1 plus. So head value is infinity means it's going to be 0. So answer is 0 here. So simply I'm saying the answer is 0. Which of the following compensation is adapted for improving the transient response of the negative unity feedback system? So it is a phase lead compensation. So answer is B here. Next one, 69th question here. The phase lead network function GC of S is equal to 1 plus S plus 1 by T divided by S plus 1 by AT. Okay, where A less than 1 would be provide maximum phase lead at a frequency of T 1 by T root A. So this is a standard formula here. So no mathematical equations are involved, right? Next one. The transfer function of a system is given by GC of S is equal to 100 divided by S square plus 20S plus 100. This series is. Just compare here. Omega n is equal to what? 10. 2 zeta omega n is equal to 20. Okay. Zeta value will be what? Omega n is 10. 10 20 means zeta will be 1. So it's a critically damped system. Next one. Okay. A series RLC circuit connected across a single phase AC voltage source. The voltage is measured across RLC are 20, 40, 55 respectively volts. An ammeter measures a current of 3 amperes. What is the power factor of the circuit here? So see here. Here we have a resistor, inductor, capacitor. Sorry, voltage across resistors is 20, 40, 55, and we have voltage source here. Now cos theta is equal to R by Z. R value is 20. We need to find the Z value. Z is nothing but square root of 20 square plus 40 minus 55 whole square, which will be equal to 20 by 25, which is equal to 0.8. Now compare here. VC is greater than VL, so it is a leading. So 0.8 lead will be the answer. Sorry. Okay. Next one. A balanced three-phase star connected voltage source has a phase sequence of ABC. If a voltage of phase A is a neutral with respect to 10 at angle 90 degrees, the line voltage VPC with respect to phase A will be. So let us consider the phase A will be like this. We have a V phase A, or VA is nothing but 10 at an angle 0 degrees. Then the voltage phasor diagram VBC will be like this. So VBC will be like this, and it will having a line voltage root 3 times that of V phase, and the angle between them is exactly 90 degrees. So lagging means 90 here, minus 90. So root 3 into 10 at an angle minus 90. So answer is D here. Okay. Next question. The Thevenin's equivalent voltage VTH in the following circuit is so simply if here is open circuited, the entire current will have to flow like this. Apply KVL in this loop, you are going to find the voltage as 46 volts. So see here, current is flowing here. So how much voltage drop? That is 12 into 3 36 volts here. Okay. Now the same voltage will be current, same current will be flowing here. So 36 volts. So 12 means 12 plus 36, and here plus 10. So 36 plus 10, 46 volts. That's it. The scalar projection of the vector 6ax plus 2ay minus 3az along with 3ax minus 4ay is, answer is 2. The following point charges are located in air: plus 0.12 microcoulombs at 0, 0 meters, and plus 0.05 microcoulombs 3, 0 meters, and 0.06 microcoulombs at 4, 4 meters, and minus 0.20 microcoulombs at 0.4 meters. First, to find the value of this, then the electric flux over the sphere of 5-meter radius. So a sphere of 5-meter radius means it should be less than 5 meters radius. Okay, from the center 0, 0. That means the radius of R1 is 0 here, R2 is 3 here, and what about R3 is square root of 4 square plus 4 square means 32 means it is more than 5. And similarly R4, which is equal to 16 means 4 here. So these are three are the valid points. So add these three values, you will get the answer. So 0.12, 0.12 plus 0.05 minus 0.20 minus 0.03 will be the answer. B. Next one. Halo conductors are used in transmission line to reduce coronal losses. Direct question. And here next one. The ring main distribution is preferred over radial distribution system. The ring main distribution system will have a good reliability. Okay, so that the voltage drop is less in the feeder and supply is more reliable. So answer is A here. Sorry. Okay, next question. The transfer function g of s has a pole zero plot as shown in the figure. Given the steady state function gain is 6, the transfer function g of s will be given here. So here we have given the numbers also given. So at s is equal to 3 minus 3 we have a pole. Sorry, we have a 0. So 0. So among the all the options check. So 0 is there. Here also 0 is there. Here also 0, 3, 0, 3, 0, 3. Okay. Next one. There is a one pole at origin. So one pole at origin means S is there. So this option will not be correct. These three options will be there. So we eliminated this option. And we have these three options. Okay. Now we have complex poles at these two values. S is equal to plus 2. Okay. So complex poles means this will not be the answer. So we have only B and C. So B and C will be the option here. Okay. B and C. So as per the bubbling YMR sheet theory, so most of the answers will be in B. So let's check the answer here. So we have selected this answer and we substituted that this gain should have a 6. So gain should have a 6 value of 6 here. So 10 into 0 plus 3 divided by, okay, so S will be 0 here. Yes, steady state gain means 0 plus 4 into 0 plus 5 here. So 5 1 ja, 5 2 ja 3, 3 2 ja 6. So this will be our answer here. I'm going for shortcut. Next one. The root locus of the system is given by. G of s into h of s is equal to k divided by s into s plus 2 into s plus 3 has a breakaway point. So to find the breakaway point, s into s plus 2 into s plus 3 plus k is equal to 0. So from this, k is equal to, okay, minus of s cube plus 5s square plus 6s. Now find the value of dk by ds and take the roots of this equation. Then we have two roots. The first one is mm, plus 4.7 or minus 4.7 divided by 6 minus 15.3 divided by 6 will get it. So minus 4.7 divided by 6 means it is going to be minus 0.7887833, and this one will be 2.55. So this one will be plus value here. If you have taken the diagram here, so we have one pole at 0, another pole at minus 2, another pole at minus 3. So between the minus 2 and 0, this will be the valid point. So this will be minus 7.833 is the answer. So answer is D here. And next one, last question of this video session here, discussion. The initial slope of the border plot that gives an indication of, so that is the type of the system here. So when you have seen that border plot diagram, so there will be a slope of like this minus degrees here like this. Okay, the starting itself. So it will represent the pole here. Okay, so that's it for this, friends. I hope you have learned something from this video. If you like this video, please share with your friends. Okay, and please comment on this video. Thank you. Have a nice day.